Hi, welcome to Raw Math. Today I'm doing a series of videos on exponential and logarithmic functions. They are, of course, inverses, and inverse functions have some fun characteristics. So with an exponential function, the inverse, the domain and range, the x's and y's flip-flop. If I could create a line y equals x, and mirror my exponential over y equals a of the x, we would end up with this graph. And this is y equals log base a to the x, because they are inverse functions. So what ends up happening is literally a and x swap, which means the domain and range flop, swap. So if the domain is all real, for the exponential, the domain, the range of our log is all real. So the domain is going to come over here and become the range, negative infinity to infinity. If the range, our y values, go from 0 to infinity, we have an asymptote. Our x-axis is an asymptote, a barrier that will not be crossed. That means over here, our y-axis is an asymptote, and our range of our domain of our log, our domain is 0 to infinity. Because it's an asymptote for both of them, we use parentheses because it will never touch. It doesn't equal. The y-intercept is 0, 1, which means over here our x-intercept right here is 1, 0. This is increasing on all values. This is actually increasing on all values. They are both increasing at all points. We just already talked about the asymptote. The x-axis is the asymptote, so y equals 0. The vertical asymptote, in this case we have a vertical asymptote, is x equals 0. And it would be as y goes to negative infinity. And both graphs are continuous. There's no holes, there's no little jumps. They're both completely continuous functions. So this is how the exponential and log look and how the different pieces act for these two inverse functions. All right, I hope you enjoyed this video. Please subscribe to my YouTube channel, and I'll see you in the next video. Thanks.